This conference will now be recorded.
So in today's class, there are two things that we're going to understand. That in abstract class, what is the use of the constructor? That's a primary thing. Okay. The second thing is like, uh, uh, how this abstract class is really useful in the project. Okay. So the abstract class is useful to achieve something called abstraction. Abstraction is one of the object-oriented principles. Okay. So let's start understanding it. Just observe, guys. Now I have defined here an abstract class called switch. I have an abstract class called switch, which has got variables, global variables, constructors, and it also has an abstract method. So this abstract method must be overridden in the subclass. Okay. Now, just to simplify it, what I'm going to do, I'm going to delete unnecessary things from this. Let me also delete this constructor. Let me write only abstract methods for your better understanding. Okay. Think about it. What I'm going to do is I explain this with just give me a moment, okay? Okay. Now observe. So I'm going to have a switch here. This is going to be the switch, okay? This is a switch. So there are two actions that you can do on this. One is switch off. You can do only actions. Another one is called switch on. So these are all the actions that anyone can perform on this, okay? So any user, let's say it can be you, new hairstyle, okay? Corona effect, because saloons are closed now. So it's you now. You can perform two actions on this switch. This is going to be the switch. That is switch on and switch off. Okay, these are all the two actions that you can perform. Now, listen to me carefully. When you switch on, what is going to happen? It purely depends on the object to object. Let's imagine here we have something called a bulb object. Here we have something called the bulb object, okay? So then the moment you switch it on, okay, the moment you switch it on, what's going to happen here? Okay, now observe. It's going to switch on. It's going to glow, right? It's going to glow and give the light to you, right? This is what it happens when you switch on in case of the bulb. Let's say now you are connected not to the bulb, but you are connected, let's say, to a laptop. If you are connected to a laptop, what happens when you switch on? The laptop gets charged, isn't it? The laptop start getting charged. So you're going to get, I think, an orange color light here, somewhere here, saying that it is getting charged. It gets charged. So similarly, let's say by chance, it is now connected to an iron box. Okay. It does not look like an iron box. Okay. I assume that it is an iron box. So this is a bulb. Okay. This is a bulb. This is going to be your laptop. This is going to be your iron box. So we are going to perform an action here. We're going to perform an action here. So the user is going to switch it on. When the user is going to switch on, it's an action, okay? It's an action. Here the user is performing an action. So what is the reaction? That reaction depends on object to object. If it is connected to the bulb, right, the bulb is going to glow, right? If it is connected to laptop, the laptop gets charged. If it is connected to an iron box, then the iron box gets heated. Very clear? What is the reaction? It gets heated. Heated. Here what happens? It gets charged. The laptop gets charged. So what happens to the bulb? It's going to glow. But observe, this is an action that we are performing here. Okay. Now these are all the reactions. Whatever this is, these are all reactions. Okay. So I'm just going to make some different marks for it. Okay. So these are all the reactions. All right. So this is an action. These are all the reactions. These are all the reactions. And that reaction purely depends on the object to object. Okay, that depends on object to object. Here it is an object, bulb object. It's a bulb object. Here it is a laptop object. And here it is an iron box object. Are you clear? So, but action is very common. So how are we going to write the code for it? It's very simple. Now just focus. I'm going to write the code for it. So I write an abstract method here. The abstract method is called switch on. So I write certain subclasses for it. I write a simple class called as the bulb. Okay. I write one subclass called bulb. Similarly, bulb is going to extend. Bulb extends an abstract class called switch. When a bulb extends an abstract class called switch, can I say bulb is a subclass and switch is the superclass? I'll repeat, bulb is the subclass and the switch is the superclass, right? And fundamentally in our last class, we learned it when a subclass extends or inherits a superclass, then we have to override inherited abstract methods. Right now, luckily, only abstract method is there, only one abstract method is there. Hence, we need to override that abstract method, right? Overriding abstract method is very simple here. You just have to take the mouse pointer on this red mark, which you are getting an error. When you take the mouse pointer, you don't have to click there. You just have to take the mouse pointer. You get two options. One is make your subclass also as abstract, which I don't want, or else you override it. You override it. I have just overridden it. Okay. So this is going to be my the subclass where I have overridden an abstract method. What happens? The bulb glows. The bulb glows. Okay. So someone please keep your microphone in muted mode. Hey, Poturi Suvarnavalli. People, they always need external, someone also keep instructing them. Who's this? Anjali, Tekumani Anjali. Good day. Mute your microphone. Fed up with telling the same thing and again and again. So similar to this, now this is the story of bulb. We are done with bulb. The second one must be the laptop. Okay, I'm going to create an object of laptop. Okay, laptop. When I create a laptop object, so here also, when I create a class called laptop, which extends the switch, there also you're going to switch on. But what happens when you switch on in case of laptop? It gets charged. So the logic is different. So we say the laptop gets charged. One second, please. Sorry for it. Sorry for it. So what happens when you switch on in case of laptop? It is going to get charged. Okay, this is the story of laptop, right? So we are done with the bulb, we are done with the laptop. Now the last one is called iron box. Okay, when I create a class called iron box, obviously iron box also is going to inherit a supermost class, right? It's going to inherit a supermost class called switch. In this case, not supermost class, the super class called switch. When one class extends the another abstract class, we have to override abstract methods here. What happens here? Iron box, iron box, iron box gets heated. Iron box gets heated. Okay, this is what it's gonna happen in case of iron box. So I have one superclass abstract class called super abstract class called a switch on, which has got three subclasses, and in all the subclasses we have overridden this logic, overridden this method, and written the different logics for it. Okay, so basically if I start writing this in class diagram, okay, this is represented in this way. So I write one superclass here. Please observe here. So I write one superclass. The superclass name is let's say the switch, and we know that this is an abstract class, correct? Extremely important. Now focus here, guys. Focus here. Whenever we write an abstract class, this is a class, okay? So here we write a class name. Here we write the class name, right? Here we write the states or the properties of it, and here we're going to write the behaviors, right? And abstract class is written by using a stereotype. Observe now these two angle brackets. These two angle brackets are called as what? Stereotypes. So here I must write a stereotype. In the stereotype, I write it as what? Abstract. If class is abstract class, then you must write like this. Okay, this is the just the UML notation. Okay, this is how we represent the UML notation, right? And it has in our case three subclasses. One, two, three. Three subclasses. So, right, this is a subclass, this is also a subclass, and this is another subclass. Okay, we do have three subclass, and it's called is a relationship, or we know that basic fundamentals, right? Okay, anyhow, uh, okay, I write it as extends. Extends, it's applicable for all the three. So what are the three subclasses we do have? One is called the bulb, which is a subclass. Another one is called iron box. Another one is called laptop. another one is called laptop. So we do have one class, and with the three subclasses. That class is not a superclass, is not as ordinary class, but it is an abstract class. Hence, we have used a stereotype here. Don't forget this. Okay, this is little important. So in the design document, this is how we represent it. Are you clear? So I had written the code for it, and also I have written, I have also written these subclasses. Now, sir, how are we going to call this? How am I going to execute it? So generally, if you look into this, okay, I'm gonna remove this, just a class, okay? Just observe, this is a simple class with the main method. I think no confusion in this. Now what I'm going to do, I'm going to access all these things. As like I said, we cannot create an object of abstract class. For example, oh shit, bulb b equal to new bulb, right? This is an object of subclass, but I cannot create an object of superclass. What is that super abstract class? Switch. I cannot write like this, switch is equal to new switch, correct? This is not possible. This is not possible because this is an abstract class. All right, but please observe, this is an error, right? This is an error, but this is possible. Very important. The first one is not possible because here we cannot create an object of abstract class. But observe in the second scenario, I'm not creating an object of abstract class, right? Object is from bulb, that is the subclass. This is reference, and the because S is a reference here, okay? The reference is from superclass. So this logic, what do you call this line of code as? Please, someone ping me. What do you call this as? Upcasting, correct. It's called upcasting. Super. Good. So you all are focused now. Good. Correct. So this simple code is called as what? Upcasting. Right? So whenever you call an overridden method, what is that overridden method? Switch on. Oh, I don't know. What is that method that we do have here? Switch on. I think, yeah, switch on. So when I call the method called switch on, now the logic, what is the logic that gets executed? Again, message me, ping me here in the chat box, ping me. The logic is executed from which class now? Yes, which is the subclass? Bulb class. Perfectly, yes. Good. So it means to say you are switching on here by using this S. Observe now, data type of S is switch. Okay. Now I'll just write this code. I'll copy this code and start explaining this here. I'll explain that here. Let's say I'm going to make it as black in color, right? And then I'm going to make it as some different fonts, maybe 26, right? Now observe this. Please observe. Here, S is a variable. The data type of S is switch. Don't forget it. S is a variable of type. Type means what? Data type. So this is called type or data type. So data type of S is switch, nothing but an abstract class. So this is nothing but an abstract class. I already explained you that abstract class is also a data type, right? And similar to this, this is an object, okay? So the object is basically from subclass. This is an object, right? This is from subclass. Since the object is from subclass and the reference is from superclass, this concept is called as what? Upcasting. Similar to this, using this superclass, the reference, right? Using this superclass reference, what am I doing here? I'm calling the method. So this concept is called as method invocation. what do you call? Method invocation. This is called method invocation. But I'm invoking not an ordinary method. I'm invoking a method which is overridden, right? So you remember two characteristics of upcasting. Out of that, the second characteristic says that whenever we call an overridden method, in case of upcasting using superclass reference, this is called superclass reference, when we call or invoke an overridden method, then logic is executed from subclass. So which is the subclass here? The subclass is bulb. So the logic gets executed from the bulb class. Clear? So yeah, okay, just come back to this. Now when I run the program, logic gets executed from bulb. So what is the logic which is present in the bulb class? In the bulb class, sorry, open implementation is from bulb. Okay, the implementation is from oh, which is the object, sorry, open implementation. I just have to select the bulb. I don't know why it's going for this. Okay, now observe the logic. What is the logic here? The bulb glows. Okay, now let us run this program. The output is going to be the bulb glows, right? In the same case, instead of this, if my program is, let's say, S1, in my reference is going to be S1, but object is not from bulb class. Let's say I'm going to create an object of laptop class, right? So now the subclass is laptop, hence the logic gets executed from laptop class. Laptop gets charged. The last one, now let's say I'm going to make it as S2, the reference name as S2, right? Now I'm going to switch on, but this object is again abstract class can be used to refer any of its subclass objects. It can be used to refer any of its subclass objects like bulb object, laptop object, iron box object. It can be used. Okay, done. So this is called upcasting typically. One second, just be online, please. Sorry guys, I got an important call, so which I had to attend. So yes, this is going to be the output. Okay, so yes, any questions now on this? Any questions on this? Please ask me questions. Please open switch class. Hey, virus, you change your name here. So your display name you change from virus. I'm fed up with this coronavirus and other things. Okay, you change your name here. Didn't you get any other name to keep? Bugger. Yeah. Okay, which subclass RKO? Bulb subclass. Okay, go through this bulb subclass. Yes, Lata. Lata is asking a question. Can I override the concrete methods of abstract class? Yes, you can override, not an issue. See, anytime you can override the concrete method. Next, Praveen is asking me a question like, what is the advantage of using abstract method or class? If the same, we can do it in overriding concept simply. Praveen, you have to wait for abstraction concept. Yes, Adarsh is asking, sir, in class, once you have shown me how to create an object of this, abstract class indirectly, that time I didn't get you. I didn't get it much. So please explain it once again. No, I didn't teach for your batch, Adarsh. Okay, basically it is called anonymous object. Okay, so whatever I have shown probably in the class, I don't know. I have not shown this in your batch, for some other batches it seems. So it's called anonymous object. So you want me to open another subclass? Yes, this is another subclass. Aniket is saying same man is coming today again. Who is Aniket? No, anonymous object I'll not show you right now, Adarsh. That's a separate topic, Adarsh. I don't know. It's a little tricky, okay? I don't want to show it right now. Smita is telling downcasting is possible. Good question. 100% possible, Smita. All right. Somnath Gaikwad, can we override non-abstract method to abstract method? Now observe here. This is one super abstract class which has got three subclasses, right? Now let's say in the super class here we have a method called void m1, a dummy method. Okay, it's a concrete method, concrete method. So what I want is I want to override that in the subclass called bulb class. Just an example, right? But what do I do? I'm not going to write any logic. I'm just going to write like this. I'm going to make it as abstract. Right here, I'm going to make it as at override. I observe here. In a super class called switch, it can be any class. Okay, this is a concrete method. Okay, concrete method means what? There is a logic here, and you're trying to make it as abstract. Right? Observe this error. Abstract method called M1 in the type bulb, that is in the subclass called bulb, can only be defined in an abstract class. It means to say now I have to make this class as abstract, correct? No, like observe now. I made this subclass as abstract because there is one abstract method. So this is a question that a student has asked. I forgot his name. So he asked me a question that in the superclass, the method is concrete. Can I override that with subclass by making it as, superclass? See, this is superclass. The superclass method is concrete method. In the subclass, I'm overriding by it at up. I mean, we never do it. We never ever do it. This is useless. Technically you are doing it, but in the again subclass of bulb class, let's say I'm going to create, let's say, another class called as LED bulb. Okay, example, LED bulb. LED bulb is a subclass which is going to extend extend bulb class. Okay, now here you have to override again the class like this. You have to override. Okay, now you cannot create an object of this bulb class because we made this bulb class as abstract. This is a good, I mean, curious question to understand, but we never do that. Who is that? Somnath asked this question. Okay. Okay, Aniket. Yeah, we cannot avoid them. Yes. We usually don't do it. Okay, we don't do it. But technically possible. Useless. Okay. Now, fine. I have this. Any other questions? Okay, now let's understand the concept of constructor with respect to abstract class, okay, which was most weighted topic from yesterday. What is the use of this constructor when we cannot create an object out of it, right? Good. So can I assume that you don't have any other questions? Please ping me. Okay, good. Okay, good, good. Thank you very much. Minimize my chat window. Now I'm going to teach you something. Okay, what is the use of this constructor? As like we all know the simple use of constructors. What are the two things or two reasons of using the constructor? Right? What are the two reasons of using the constructor? First one is we call it by using new. We call it by using new keyword to create an object. Right? This is an instruction for JVM to create an object. This is the first one. What is the second use of it? It is used to initialize. It is used to initialize states. Right? It is used to initialize states of an object, correct? States of an object at the time of object creation. At the time of object creation. Correct. So these are all the two uses basically of a constructor in Java. Now, definitely, when I compare when I take constructor, when I consider constructor with respect to abstract class, the first thing will not be of much useful because definitely we cannot create an object of abstract class. Hence, you cannot use the constructor from the perspective to create an object. So the uses of that, because we cannot create an object of abstract class, so there is no point in you having constructor for object creation. But observe, it can be used. It can be used to initialize some resources. It can be used to initialize some resources. All right. So what do you mean by that? Observe. I'll try to write this example. So I have one superclass called mobile. Try to understand it. I have a superclass called mobile. This is my superclass. And I'm going to make this class as, let's say, abstract. My superclass is abstract. There is a super abstract class called mobile. This abstract class called mobile has, let's say, two variables. Okay. One is called model, right? Another one is called, let's say, price. Okay, or I'll take this as color, okay? So color of the mobile and price of the mobile. So this is integer and the color is string. string. Okay. So what do I do? Now I write one constructor in the superclass to initialize. Which color should I select? Okay, select this class. Okay, so I'm going to create a constructor here. Please observe. Slowly, I'm introducing to constructor in case of this abstract class. Okay, the purpose of this is to initialize, which I'm going to do it here by taking some parameters, let's say. Okay, so the parameters are going to be something like this: string color, integer price, integer price. There should be a comma separation between two parameters. Okay, and this is the close of the class. The class starts here and the class ends here. This is the scope of the constructor. So what do we do inside the constructor? We initialize the resources. We're going to initialize the resources, right? So how are we going to initialize the resources? This dot color equal to this dot price equal to. See, man, how much of the colors that I'm using. See here, discount. So this C and P, which is in green color, these two are local variables. The CLR and price, which is in wine red color, these two are the global variables, right? I'm initializing. So this is an example where now observe, this is an abstract class. Never forget, this is an abstract class. Abstract class can still have the global variables and constructor, right? Possible. Right now, I'm not written any abstract method because my intention of this program is to explain the constructor, not to explain the abstract method, because you already learned abstract method. So I do have only one constructor right now. Is it a default constructor or custom constructor? Think about it. Custom means user-defined constructor or parameterized constructor. The answer is that it's a parameterized constructor. So obviously, the compiler does not generate any default constructor in this class, correct? Now, what do? I write one subclass. Now, I'm going to write a subclass. I write a class called as, right? Let's say smart mobile. Smart mobile. Smart mobile. Right, smart mobile. See, every mobile are different. Smart mobile is different from old, typical old mobile, right? I have a smart mobile which extends. Smart mobile extends, let's say, a class called mobile class. Smart mobile has extends a mobile class. It means to say this is a subclass of the abstract class. Okay. Now, what do? I'm going to write one variable in this subclass, and that variable is going to be, let's say, string operating system. What is the operating system present in this smart mobile? Is it an iOS or is it an Android or is it an Windows? Which operating system? Again, another variable. Okay, this is another variable. So what do I do now? The subclass, right? In the subclass also, I'm going to write one, let's say, a constructor called smart mobile. There's something called smart mobile. Observe, this is the constructor of the subclass. Carefully observe. Now this is going to take a local variable called string operating system, right? It's going to take string operating system. So I have to initialize this dot OS equal to OS. this dot operating system, nothing but instance variable, right? This OS is an instance variable equal to this OS, nothing but local variable, right? So here is a condition of variable shadowing. Observe, a variable shadowing is a concept where an instance variable or a global variable name and the local variable names are same, right? So instance variable name and the global variable names are same. But in that case, to differentiate between a local variable and an instance variable, we use the keyword called this. So I'm initializing it here, right? So this is the starting of the class and this is the end of this class. Okay, it should be in black color. Okay, it should be end class. I have a super class, super abstract class called mobile, and I do have a subclass called smart mobile, which extends the mobile, right? In the super class called mobile, we have two variables which are initialized by a parameterized constructor. And in the subclass also, I do have a parameterized constructor. Now observe. Right now I'll explain you. Just observe this for 10 seconds, okay? So without our knowledge, without our knowledge, automatically in every constructor, listen, in every constructor, automatically in the first line, there is going to be something called super call. Try to understand it, super. Here also, in this first line of constructor, there is, I don't have space there, that's why I'm writing it here. There is going to be something called super, right? Now observe. When you, we don't write it, automatically it is written by the compiler, right? See, when we say super in the constructor, what is the super class of this mobile class? Tell me. The super class of mobile class is the parentmost class called object, which is there in the Java library. Yes, of course, this class has a default constructor, and that constructor is called, because we are not passing any arguments here. So it is nothing but it's going to call the default constructor of which class? Object class. And in the object class, there is a default constructor. Well and fine. This is not an issue at all, right? This is not an issue. It works perfectly correct. Works. The problem starts here. Now we are calling in the subclass, we are not we, automatically this line is going to be called. So what is the meaning of it? Super is a way to call. This is super is a way to call our chaining, constructor chaining. Right? What does it do? It's going to automatically call immediate superclass of the smart mobile. Who is the superclass of smart mobile? Mobile. In the mobile class, where is the default constructor or zero parameterized constructor? Show me here. There is only one constructor called mobile, but this bugger is taking two parameters. This is not called, right? This is not called. So hence here it starts giving you an error. So when I write this program, it gives an error. All right. So let me write this program in Eclipse. Okay. I make it as, let's say, an abstract class called mobile. I do have string color integer price, right? string color, right? This is going to be my constructor. This is called a parameterized constructor in the superclass called mobile, right? So, but automatically, what is there in the first line? Super. This is going to be there in the first line, right? It's going to call superclass, which is the superclass of mobile class, object class. So hence it is going to chain to object class default constructor. So when I say class name with parenthesis, it's called constructor. Okay, chain to object class default constructor. Good. So now I'm going to write a class. I should not write in one file, but for better visibility, I'm writing called smart mobile, which extends, okay, mobile. So now I'm going to have a variable called string. Already started giving error, compilation error. It's already there, the compilation error, just observe. Okay, so I'm going to have this operating system. So I'll write like, constructor using field. Yes. Now observe. Now here it's giving an error because automatically what happens? Automatically in this, there is something called super with the zero parameter automatically. Okay. So in the super class called mobile class, there is no zero parameter constructor. So, but the fundamental reason of having the constructor be a concrete class or it can be an abstract like this. So what am I doing? Initialization. Initializing this. Here also same thing, I'm initialization, right? That's why what you're supposed to do is the constructor which is there in the, if someone asks you what is the reason of having constructor in an abstract class, you should never say it is for object creation because we cannot create any object, right? That's the reason. The only purpose of having constructor in an abstract class is to initialize instance variables of abstract class. I'll repeat, it is used to initialize instance variables or global variables or states of an abstract class. Okay, that's the reason. Now, understood everyone? So how it, okay, so now what I'm going to do now from the subclass, I'm going to pass some variable. Let's say the color of the mobile is going to be gray, all right? And then, okay, not this. Sorry. This is the kind of program that I had written here. Observe here, the smart mobile is taking only one parameter. So I've written only one parameter called operating system, which you are initializing. The first thing is going to be, let's say, gray in color, and the price of the mobile is, let's say, 25,000, right? But this is called hard-coded value. Always it uses gray and 25,000. To call a superclass constructor, which is zero parameterized constructor. If you don't want that to happen, what you're supposed to do, you have to call explicit super. This is called explicit super. So this is called explicit chaining. Okay, explicit chaining. So you are chaining it explicitly. All right. So when I chain it explicitly to the constructor, now this subclass constructor is chained to superclass constructor. Are you clear? Now, if I want to create an object of smart mobile, what exactly happens here? Observe. I'm going to create an object of the subclass. What is the subclass name?
Sir,
Sir,
you
you
are
are not
not
audible.
audible.
Arey yaar, I'm not able. From when? Shit, 1 second. Network issue. Something. Audible, not audible. Okay. From when I'm not audible? Sorry. Are you able to hear me now? Hello? 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 Are you guys able to hear me? Are you able to hear me? I don't know. If you are able to connection lost, please check the network. Oh shit. Within 60 minutes. My end. 1 second, please. Hello guys, I'm back. Sorry for this. Are you able to hear me now? Are you able to hear me now?
Yes, sir.
Okay, thank you. I'll just repeat, assuming that you are lost when I was explaining this chaining part, right? So here I have a subclass which is going to extend the superclass called mobile, and we have a constructor. It need not to be public. Okay, so you already know what is the meaning of public, private, and other things. So what I doing here is usually if I don't write like this code in line number 13, automatically it's going to call the superclass constructor using super with like this, correct? So when automatically it calls super without the parenthesis, it means to say it is trying to call a superclass zero parameter constructor, but unfortunately, which is not present in our superclass called mobile. In the superclass mobile, we don't have a zero parameterized constructor, hence we are getting an error. So if you want to remove this error, so you have to explicitly call the constructor which is there. The constructor which is there in the superclass is taking two parameters, hence you are supposed to call it by using super and pass two arguments. All right, so now anyhow we cannot create an object of superclass because it is an abstract class, but it can be used only to, right, it can be used only to refer, right? So how are we going to do it then? So I'm going to write a code like this: mobile m, which is nothing but a reference, equal to new smart mobile, right? New smart mobile. So what am I going to do here? What am I doing here? So this is a superclass reference. This is a subclass object. But subclass called the smart mobile is taking one parameter in the constructor. Observe, there is one parameter in the constructor. So now I'm calling new smart mobile. I'm going to pass an argument like Android. Right? So now there are many things here to explain. So basically, this is a reference. This is a reference, right? So a reference of which one? Reference of abstract class, right? I write it here. Abstract class reference, right? This is called subclass object. These are all object of this subclass, okay? And this is an argument that we are passing. Whenever we call like this, the argument called Android gets passed into this. So now argument goes here. So what is the value of OS? Well, the value of OS is Android. So in the first line, you are chaining it by using gray and 25,000. Please observe. When an object of smartphone is created, it usually gets created in the heap area, right? So one object gets created, right? It's an object of which class? Smartphone. It's an object of smart mobile, right? It's an object of smart mobile. When an object is created, observe subclass object is created. Okay. Now, what are the variables of subclass? Most of the students say only OS. No, it is inheriting mobile. Hence, mobile class variables and methods also gets inherited. But in this case, there are no methods, so variables also gets inherited. One is called color, price, and its own called OS. So three variables are there. Okay, one is called color, another one is called price, another one is called OS. These are all the three variables which are present in this. So what is M? M is only a reference. Okay, M is only a reference which is oh, 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 oh. Okay, this is a reference which refers to this particular object. All right. So there are three variables: color, price, and OS. So what's the value of this color now? Right now, the value of the color is, sorry, OS is Android, right? So also in this program, you are initializing, you are passing gray and 25,000 as an argument to the superclass constructor. That is going to initialize the color to gray and price to 25,000. Here, the color, the value of the color is going to be gray and the value of the price is going to be 25,000. All right. So don't ask me, sir, you're writing gray in blue color. Okay. It's just the pen color is blue. So this is how it really works. You understand now? But this is also not a good practice. This program works properly, no compilation error, no runtime error, but not a good practice because I'm hard coding the value to gray and 25,000, right? It is always gray and always 25,000. You create an object of 100 object, 100. You create 100 objects of smartphone, smart mobile, then you are going to get the same value called always gray color 25,000, gray color 25,000. Instead of that, I'll make it to take three variables. Let's say one is operating system, all right, another one is called string color, another CLR, like another something called integer price, right? Now what do? I initialize the operating system here, but these two things I'm going to call by using CLR comma PR. So now I take the value of color, I take the value of price, and I pass it to the superclass constructor, which is going to initialize color and price. But here in the subclass, I'm initializing operating system. So now, how many arguments that I should pass to this particular constructor? This is not going to work now. What I'm going to do is I need to pass three things. Okay, one is operating system, color, price. Correct. So observe here, please. Yeah, it's very sensitive. So now I need to erase this. I need to pass three arguments. Now one is called this. Let's say now color of the mobile is going to be, let's say, black. Just black is going to be the color, and price is going to be, let's say, 20,000 rupees. 20,000 rupees. Okay. So now the color is not going to be gray here, and color price is not going to be this, right? What is that? Right now, color is going to be black. Okay. The value that is price is going to be 20,000 rupees. So this is how it's going to work now. I hope things are clear. So the answer is very simple. The purpose, okay, the conclusion is this. The purpose of the constructor of an abstract class is to initialize the instance variables or the states of an abstract class. And it cannot be called by using new keyword. Rather, it can be called by its subclass using super. Are you clear? So remember this. I'll just write somewhere here. We cannot create we so this is the story. Now observe, we cannot create an object of abstract class, object of abstract class. Hence, abstract class. Hence, abstract class so constructor can't be called by using new keyword. Very important, cannot be called by using new keyword, right? So abstractor, next point is that abstract class constructor can only be called by its subclass constructor using super. That is nothing but chaining. That's nothing but chaining. Are you clear? This is an important point. So this is the story of the constructor of an abstract class. So where is that? Now I do have something like this, right? Yes. Fine. So you can ask me questions if you have in the chat box. Now observe this code. I can minimize this a little bit. Now observe this. It's clearly visible, one window, okay? So any questions right now on this? Sir, show blueprint of abstract constructor. What do you mean by blueprint of abstract constructor? I didn't understand. Pankaj, you are wrong. Not possible, Pankaj. You can add any number of parameters, Smita, in subclass. Anu is asking me question, is there any other way of calling without using explicit chaining? No. See, constructor can be called by other constructor only in two ways, either by using this or by using super, correct? No? So if you write one more constructor in the super class called mobile, then you can call this constructor by the another example, just an example, okay? A dummy example. So let's say you want to call this one from here or this one from here, then you have to call it by using this, all right? This with something you have to pass, like, you know, null, ding, 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 something you have to pass. Okay, this is one more way. So basically, it can only be called by either by using this or by using super. Only two ways of calling a constructor. Vijay, what is the flow of execution? The flow of execution is that here I have written, let's say in this code, this is my, let's say this is going to be my main method, observe. Sorry. Assume that this is going to be my main method. If this code I write it in a main method, then if I write this program in the main method, the program starts from here. It's going to call the new smart mobile. When I call new smart mobile with an argument, 3 arguments. So firstly, it's going to call the new smart mobile constructor. It executes the line number 12, and then it goes to line number 13. When it goes to line number 13, right, then it goes to a super class, that's line number 4, and starts executing this line number 4. And in the line number 5, it's going to call the superclass. It goes to superclass called object, executes the default constructor of object class, comes back, then initialize, that is line number 6, line number 7, and then it comes back to this and executes line number 14. And after that, line number 15 goes back to the main method. That's it. This is the flow of execution, Vijay. What is the Aniket is asking me question that I have a doubt in line number 13. What is that doubt? Aniket, what is that doubt? If you are getting doubt in line number 13 means 100% sure you haven't gone through the constructor chaining which I taught in my previous class. I have taught constructor chaining. Thanks, Vijay. Super, done. Thank you very much. So that's about this abstract class. So we learned what is abstract class, what is abstract method, how to override it, how to, how to call the constructor, what can be there, what cannot be there, what is the difference between abstract class and concrete class. So these are all the fundamentals that we learned. Okay, good, good. So in tomorrow's session, we're going to talk about interface, the most important concept which you are not supposed to miss at any cost. So, okay, so don't miss tomorrow's class. Thanks for attending today's session. Okay, I'm going to conclude today's session. Thank you very much.